This is section 8.3, rotation. Our objective today is to graph rotations and identify rotational symmetry. Let's start with vocab. A rotation is a transformation that turns a figure about a fixed point. The center of rotation is that fixed point about which a figure is turned in the rotation. The angle of rotation tells the number of degrees the figure rotates. All the way around would be 360 degrees. A rotational symmetry is if a figure can be rotated 180 degrees or less and exactly match its original figure. Let's start with rotational symmetry. So if I take this starfish and I turn it, it's going to end up looking exactly the same. So how many times would I turn it to get back to the original though? Well, I would turn it once, twice, 3 times, 4 times, 5 times to get back to the original. All the way around is 360 degrees. So divide that by the 5 turns. And we have 72-degree rotational symmetry. That means if I turn it 72 degrees, it lies exactly on itself. Try this one on your own. All right, the first question is if I take this and I turn it, will it land exactly on itself? The answer is yes, it does have rotational symmetry. The second question, yes. The second question is what is the angle of rotation? Well, let's take this point. It turns to here before it looks the same again. It can't turn to one of those black ones because the black ones are kind of behind the white stuff. So it would turn twice, 3, 4, and 5 times. I take 360 degrees divided by 5, and I get 72-degree rotational symmetry. Now here's the big thing for today, graphing rotations. All rotations will be counterclockwise, unless you are specifically told otherwise. The rotations will also always have the origin as the center. So here are our rules. For 90 degrees, a point AB, let's say my point is -2, 1. So A would be -2, B is 1. So for 90 degrees, negative BA becomes -1, -2. For 180 degrees, AB becomes -A, -B. That just makes both numbers become their opposites. So we get 2, -1. And for 270 degrees, AB becomes B, -A. So B stays the same, and A becomes its opposite. So we get 1, 2. Let's try this. We're going to graph this triangle and its image after a rotation of 90 degrees. So let's start by graphing our original one. 3, 3 is point A. 3, -2 is C, and 1, -1 is B. So there's my original triangle. Now for my image, my rule says for 90 degrees that AB becomes -BA. So A prime will become, this 3 becomes its opposite and moves to the front, and A stays the same. So -3, 3. So right there is A prime. B prime, this is my B right there, -1, so it becomes a 1, 1. So there's B prime. And C prime, my B coordinate is -2, so it becomes its opposite, so 2, 3. And there's my image. Notice that it looks like it was turned 90 degrees about the origin. Try these 2 problems on your own. All right, let's start by graphing them. Here's A, B, and D. There are my original points. So for 180, A prime becomes, just both coordinates become their opposites. So it becomes 5, -2. B prime is 6, 1. And D prime is 2, -1. Let's look at what that looks like when it's graphed. Notice that D is still the closest point to the origin. B still looks like it's the furthest away. And it's just kind of turned around. For 270, A prime would become 2, 5. Because remember, in this case, the A becomes its opposite when it switches. B prime would be -1, 6. And D prime would be 1, 2. So we have 2, 5 for A prime, -1, 6 for B prime, and 1, 2 for D prime. Notice that all three of these triangles look exactly the same, just turned. Here is your assignment.